Now see here, a transverse displacement of a string clamped at its two ends is given by yxt is equal to 0.06 sin 2 pi upon 3 x cos 120 pi t, whereas the length of the string is 1.5 meter, mass of the string is 3 into 10 raised to power minus 2 kg, x and y are in meters and t is in seconds. First part of the question here, does the function represent travelling or stationary wave? So, now see here, for the travelling waves we know it here, y is equal to a sin omega t minus kx. So, x and t both are occurring here in the same part, and here these two functions are here the different. So, x is here and t is here. So, x and t variables are here representing the two separate functions. Therefore, this wave is not a travelling wave, this is an example of a stationary wave. So, now see the second part of the question, interpret the wave as a superposition of two waves travelling in opposite direction. So, you have to show here this thing is here the thing is obtained after the superposition of the two waves travelling in opposite direction. Now, then find lambda, v and nu of each wave. So, see here, to show that this is obtained after superposition of the two waves, we can take y1 is equal to this a sin omega t minus kx and y2 is equal to a sin omega t plus kx plus pi, because this is incident wave, this is the reflected wave and the reflection takes place at the rigid boundary. So, there is a phase reversal of pi. So, we can write minus a sin omega t plus kx. By solving this y is equal to y1 plus y2, we get minus 2a sin kx cos omega t. So, this is similar to this. Therefore, we can say that this is actually obtained after the superposition of two waves travelling in opposite direction. So, now this is kx. So, obviously, this is representing here kx. So, we can write here k is equal to 2 pi upon 3 and k is equal to, we know it, 2 pi upon lambda is equal to 2 pi upon 3 cancel. So, we will be getting lambda is equal to 3. So, the wavelength of this here, that is a 3 meter here we have obtained. So, the wavelength we have calculated. So, now we can calculate here frequency and velocity. So, this here omega t is equal to this part, that means omega is equal to 120 pi. So, omega is equal to 120 pi and that can be written 2 pi nu is equal to 120 pi, pi cancel. So, nu is equal to here 60 hertz. So, we have got frequency nu is equal to 60 hertz. If we have got frequency 60 hertz, we can calculate its velocity also. So, velocity is equal to frequency into lambda, that is 60 into 3 is equal to 180 meter per second. So, this is here velocity. So, we have calculated velocity also. Now, see here third part of this question is determine tension in the string. So, see here the speed of the wave in the string is v is equal to under root of t upon m. We have already calculated 180 meter per second in the previous part of the question. M is here mass per unit length, we can calculate total mass is given to us 3 into 10 raised to power minus 2 kg and length is 1.5 meter. So, the mass per unit length is 2 into 10 raised to power minus 2 kg per meter. So, this we have got m. So, we have got m, we have got velocity, easily we can calculate t. So, t is equal to v square into m. So, 180 square into 2 into 10 raised to power minus 2 kg per meter, and if you solve it, you will be getting 648 Newton. So, this is the total tension in the string.